Vessels produce a number of pollutants with health effects, primarily nitrogen oxides and particulate matter. And we have used a number of techniques, both on board the vessel, but also in port activities like what we see behind me to measure these emissions. We have tested a number of techniques in order to make sure that vessels use the right fuel and proper emission control as required by regulations in order to fulfill the environmental regulation in Europe. SCIPPER has been a Horizon 2020 project funded by the European Commission, and we want to see in different locations how much pollution from ships is, and also to find solutions in order to decrease the air quality problems caused by shipping.
In SCIPPER, we focused on a number of emissions to monitor on board with sensors. This included, or this was primarily focused on NOx and different forms of particulate matter monitoring, including black carbon. And also in our overall system, we defined standard data formats, and we transmitted data via SIS data transmission, satellite data transmission, and developed a central emissions monitoring system.
We have made great progress in the SCIPPER project to understand what's the uncertainty of the methods that we are working on. And we have done a lot of comparison and things like this, and comparison to onboard sampling. So I think we can definitely see ships that are above 0.18% in fuel sulfur content. And we understand quite well now what we should work with in order to get the threshold for the detection a little lower.
So what SCIPPER does is we have used the very well thought of experiment with very latest high-end instrumentation to characterize both the gas phase and particle phase emissions of shipping. What happens with this characterization is that we produce emission factors for different compounds that can be later used in modeling. Of course, we also produce scientific information on what kind of compounds we have and what happens to them in the atmosphere.
In SCIPPER, we improved emission inventories for shipping quite significantly. For example, we considered waves, we considered load-dependent emission factors, and we also included new species like volatile organic compounds and ammonia into the emission inventories. We put these emissions then into atmospheric chemistry models, and we didn't only use one model, but we used 5 models to ask the same question: what is the air quality because of shipping in the Mediterranean regions? In the end, we also try to harmonize the modeling approaches to cover regional scales, continental scales, and also go down to harbor scales with the same similar approach. So we use harmonized emission inventories and harmonized input data for our modeling.
I think in SCIPPER we've done a lot of progress on measuring several of these pollutants with sensors, for example nitrogen oxides, which definitely is already regulated, could be harder regulated, and there could be regulations about having sensors on board, and we have shown that they would work. Other sensors we have tested are, for example, for black carbon, and they are different sensors, and that when those regulations come, that could work also. There still has to be more tests done for sensors for nitrous oxide, for example, which might be a problem with new fuels coming. And for methane, there are sensors available. They can be used to monitor the methane slip from natural gas ships.
SCIPPER has measured a great number of vessels in terms of their emissions, has deployed a number of techniques in different places in Europe in monitoring shipping emissions, and has simulated the impact of vessels to air quality in different coastal areas in Europe. We sincerely hope and we believe that the results of the project will be very useful to policymakers in dealing with vessel emissions and improving the air quality in Europe.